Hey, thanks for joining me for a few minutes to go over the review for the upcoming exam. This is our 12-week assessment coming, and our goal in there is to really kind of review some of the main concepts. This is not to cover every single thing that we've done in class, but just to make sure that we have broadly gone through the major concepts that we think are really important for us to know. So anyway, we'll see if we can go through, I believe it's the first about 9 questions in this particular video. I think that should time it well. But one of the first things that we decided we wanted you guys to be able to do would be to take a look at a statement and be able to write that down pictorially and represent accurately what you've been given. So this says that I've got some line N that is the perpendicular bisector of segment CD, excuse me. So what I'm going to start with right here is I'm going to make my nice little segment CD. Guess I got a little close to the edge of my paper there, huh? So here's CD. And I've got some line N right here that is going to hit it at a 90-degree angle, and it's going to hit it smack dab in the middle so that it cuts it in half. So interpretively, I've got this line N. Now remember, a line should have 2 points on it. So you can either make it based on 2 coordinates, or you could make it a lowercase cursive letter. And we tend to do that sometimes. So this is the story that we have, that it hit at a 90, that's what the word perpendicular indicated, and that somehow these 2 pieces right here should be exactly the same length. So now we can analyze our story. Is it true that CQ and DQ are in fact the same? Well, that would actually line up very well with the definition of the word bisector. Second, is it true that the distance all the way from C to D, the segment all the way from C to D, is the same thing as the distance from Q to D? Because remember, we said Q is the point where they cross. Well, that's not true at all, because CD is the entire segment and QD is really only half of it. And then the last, that if I doubled the distance or doubled the segment from C to Q, would that be exactly what CD is? Well, you can see that CD is in fact 2 of those put together, so that's a true statement. Okay, moving to the second one. Now, remember, we always are going to want to utilize the diagram, but it says in the given information, angle W is congruent to angle Z. So let's put that right here. I know that this angle and this angle are congruent. So it's intelligent for us to mark those. So effectively, they're giving me alternate exterior angles. And I want to be able to try to find out or establish if this line M right here is parallel to that one right there, which is line N. Now, it doesn't say that they are. I'm trying to find out if, in fact, I can indicate that they are. So second story is every time you see that X, and we clearly have that story right here where you see that X, every time you have an X, those values across from each other are the same, that Y and Z have to be the same, and that's called the vertical angle theorem. And the vertical angle theorem is a very simple theorem that says vertical angles are in fact congruent. And they're always going to be congruent no matter what. I cannot break them. I cannot make an X and make the 2 angles that are across from each other fail to be congruent. It's impossible. Now, this is a hint. The transitive property is that thing where you have a bridge, that W is congruent to Z, but the value Z right here is also in turn congruent to Y. And so it's almost like a bridge, that Z is a connector between both of these statements. So angle W is congruent to angle Y. And our last little statement is that M is therefore parallel. And this is really what I was trying to get to, is because now I have W and I have Y, and these are corresponding angles. And that's really what I wanted to get to, because corresponding angles is the most direct way to visually see that 2 things are in fact congruent. And so we're going to do that. And that's called the corresponding angle postulate. Now, I am going ahead and I'm abbreviating that a little bit. Corresponding angles are a postulate. The other ones tend to be proofs because we use the corresponding angle to get there. Now, as it turns out, this is a 2-way street. If we start with parallel lines, then the angles are congruent, like W and Y. But if W and Y, then the lines are parallel. It goes the other direction. And it actually works in both ways. This one is technically known as the converse of that. because the other way says if they are parallel, then the angles are congruent. This just goes the other direction. So moving on to number 3, we talked about parallel for a little bit. We also talked about perpendicular for a little bit. The key here is that parallel lines and perpendicular lines have something that is important that relates to their slope. So what we're going to do real quick here is look at a quick Desmos demonstration. So I have a line right here, 3/5 x minus 7. I've got a y-intercept of -4, and I'm going to make a quick graph that has a slope of 3/5, just like the original. But I'm going to put a plus b right here, and I'm going to move this around. And what I want you to notice is that as long as I make the 3/5 the slope, the b value is going to be changing. The place where it crosses the y-axis changes, but no matter what I do, those lines are going to be parallel. But if I want it to also have that right y-intercept, I just have to slide it down until those coincide. And so notice if I make b -4, that would achieve what I've asked for. So what we want to do is we want to come in here and make an equation that looks like y equals mx plus b. M is the slope, but I want the slope to be identically 3/5. B is the y-intercept, but I told you I wanted that to be -4. So that's all it takes to do that. Now, again, I could have all sorts of other parallel lines, but that's the only one that is parallel and goes through that coordinate. Now, we can switch this up a little teeny bit too, because if instead of looking for parallel, we looked for perpendicular, what we're going to do is we're going to take the original slope that we had, which was 3/5, and we're going to make it positive 5/3. Notice that instead of 3/5, it's 5/3. And instead of making it a positive angle, I'm going to make it negative because that's the opposite. If it was positive, I made it negative. If it's negative, I make it positive. It's opposite and reciprocal both. Now, just like before, as I slide this thing around, no matter where I go, as long as I make the slope opposite and reciprocal, it will in fact be perpendicular. And I just have to slide it over until it has that correct value, which again has a y-intercept of -4, like we would have predicted. So if you want to have perpendicular lines, we go right back to the well and we say we want y equals mx plus b. I would like to have a slope of -5/3. That's again opposite and reciprocal. And I want a y-intercept of -4. All right, I'm going to try to start going a little quicker through a couple of these. If I wanted angle 1 and 3 to somehow tell me that these two slopes right here, these two lines were parallel, what relationship would do that is I would say angle 1 would be congruent to angle 3 because that would be corresponding. Now, again, that would be corresponding. This would be the converse because I'm making that happen so that the lines are parallel. But that would be the angle that would prove that they would be parallels if those are the same. Now, if I change colors a little bit, I'm going to go red and we talk about angle 2 and 3 instead. Well, 2 and 3 are definitely not the same. Those are totally different values. They're both on the inside. That's going to be called consecutive interior. So my apologies if marking them that way made it look like I was saying they're the same. They're different values that I just wanted to color them red. You can actually see this one looks obtuse and that one looks acute. So what has to be true is that angle 2 and 3 are supplementary. Now, keep in mind, I'm using the word supplementary, but if you wanted to say that there's sum of those angles was 180, that the measure of angle 2 plus the measure of angle 3 is 180, that would be fine because you would just be using the definition of the word supplementary. Now, if lines, what would be true between 2 and 4 if they're not parallel? Well, see, 2 and 4 are also consecutive interior angles, so I would want angle 2 and angle 4 to not be supplementary. I would like them to add up to a value that is in fact not exactly 180 degrees. So even if it's 179 or 184, if they don't add up to perfectly 180, then those two lines would not be parallel. Okay. Number 5, I wanted to see if I could get through these, but I wanted to try to come up with a situation of what those values would be if these lines are in fact parallel, or what they would have to be to ensure that the lines are parallel. Well, right off the bat, I can see that these two angles, y and this 106, are corresponding angles. So I immediately know y has to be 106 because corresponding angles of parallel lines have to be congruent. But by that same logic, the 4x plus 6 is also corresponding because they're both looking this direction in the upper right-hand corner. So 4x has to be 106. We're going to subtract 6 from both sides. And I got x is 25. So as long as x is 25 and y is 106, that's going to force those lines to, in fact, be parallel. Or that would say if they are parallel, then those would be the values of those things. And that really is just kind of how it works. So just finishing these last two, these two angles are called alternate interiors. And you'll notice this guy looks kind of acute, a little less than 90. So does that. You can tell that those two angles would have to be the same as each other. I think I would subtract A from both sides, and I would get that A is in fact 28 degrees. So that was a fairly easy thing to solve. And so I also want to find the angle MNP. So M to N to P is right here. So I'm supposed to plug in the number 28, and 28 plus 28 is 56. So this is 56 degrees. And the very last one for this video is, again, we have consecutive interiors. So if I were to take these two angles together and add them together, now keep in mind that one looks obtuse and this one looks acute. They would not be the same as each other. They're going to be supplementary. So we're going to combine our like terms. 3n plus n is 4n. Negative 47 plus 7 is negative 40. That's got, let's add 40 to both sides. That's going to give me 220. And so I got n is 55 degrees. So we're most way there, but then I just also would like to find out what is the measure of angle A, B, C. So remember, always just trace the angle. And according to this, it would be 3n minus 47. But I told you that n is 55. Now, if n is in fact 55 and I plugged it in, 4 times that minus 47, just use a calculator or sketch that out on paper, you're going to get 118 degrees. Now, most of you would probably stop there. I don't. I do one more thing, because if I know that this angle right here is 118, I'd also like to do something else, because 55 plus 7 would be 62. And I can see that these two things do, in fact, add up to 180 degrees, which validates the fact that they were, in fact, supplementary and that I did do my arithmetic correctly, or my algebra. So hopefully that was helpful. That was the first, I guess, 5 questions, and I will see you back in class later. Thanks for joining me for a few minutes. Bye-bye.